Good evening everyone. This is CM1 first demo lecture. Okay, so we are talking about core mathematics 1. Now just give me 1 minute. Okay, so core mathematics 1. So at any time if you have any question, you can unmute yourself and ask directly, or you can write it in the chat. I'll be monitoring the chat the whole time. Okay. Now core mathematics 1 CM1 is one of the first subjects that we study. It contains two parts. We have financial mathematics and we have life insurance. Call it as life contingency. Okay. So the course is divided into these two parts. When we talk about financial mathematics, we are going to go from very basics of finance, that would be simple interest and compound interest, and go up till how to analyze any financial instrument or financial body. Okay, so first 14 chapters is about financial mathematics. Okay, so these first 14 is FM, and from 15 to 28, here it's showing only 23 because we have here. Okay, so this is LC, this is also, these are also LC, life contingency. So first 14 chapter are the financial mathematics part. Rather, chapter 1 and chapter 2 of this book has been removed. So you'll say chapter 3 to 14 are the financial mathematics, and chapter 15 to chapter 28 are the life contingency. Okay, that's the life insurance part. So we'll of course start with the financial mathematics part. Even in this financial mathematics part, you will find that from this chapter 3 is a theory chapter that talks about the whole course. Okay, so you don't have to worry about it right now. We'll study that at the end. We start with chapter 4. So we'll say chapter 4 to chapter 10. These are the basics. Okay, so from chapter 4 to 10, these are the basics of financial mathematics. And from 11 to 14, we have application. These are the application of all the basics that we are going to study. Similarly, when we are studying life contingency, we'll first have basics. So from chapter 15 to chapter 19, these are the basics. And then from chapter 20 to chapter 28, these are the applications. Okay. Rather, you might say this chapter 22 is also a basic chapter. Then we come up here, this computing risk, this is also a basic chapter. Others are applications. So the course is divided in such a way that we study first the basics and then we study the application part of that subject. Okay. So we'll be starting with the financial mathematics, that is chapter 4. We are going to talk about the time value of money. Okay, I've just realized that many people might be completely new to actuarial science. At any point, if you want to know anything about it, you can write it in the chat or ask me. Okay, so if you want to know about the institutes or the course or anything, just let me know. I'll start with that first. Otherwise, we'll just directly go to time value of money. Okay, so you're asking what will be in the recorded lecture. See, whatever we are studying throughout the course, we record it. Okay, so if you are buying recorded lectures right now, it will be the past years recorded lectures of the live lectures. So the lectures that we are doing right now, like online lectures, we record them, and that is given as recorded lectures. So they are just lectures of the previous session. Okay. Anything else? Chalo, let's start with the time value of money. Now, whenever we talk about value of money, okay, what are the different values of money that we can talk about? Anybody? I like the lectures to be a little bit of interactive. I would like you all to also contribute. It does not matter that you are correct or wrong. We are here to learn. So always remember, contributing helps us realize what mistakes we can make. So if you are right, well and good. If you are wrong, no problem. We'll learn something new, right? So I would like all of us to interact. Okay. So you can type, you can unmute yourself and answer whenever I ask a question. So when I say values of money, what are the different types of value that comes into your mind? Have you heard about face value? Okay. Now there is face value, there is market value. Okay. Now you might have heard about face value and market value of other kinds of assets. Now actually money is not a physical item. Okay, money is not a physical good. It's not actually an asset. Can you tell me what a money is? If I ask what is money, what is money?
Means used for monetary transaction.
Means for monetary transaction. The word monetary comes from money, right? So but means of exchange. Okay, so we'll say it is a means of exchange, right? Standard of payment, that is also correct. A standard of payment, good. Okay, then we have another promissory note. It's the legal name. I'll talk about that also. Promissory note. Okay. This is the reason why we call it as a note. Okay, in India we call it as a note because it's a promissory note. In America they call it as promissory bill. That is why their currency they call it as a bill. Okay. Now when I say means of exchange, okay, so money is not a physical item. We created money so that we can value my own goods that I'm trying to sell, and the other person who is trying to buy would understand that value. So it's a medium by which we value other items, goods and services. So you can say it's a medium to value goods and services. That's the real definition, I would say, of money. It's a medium to value goods and services. So it's not a physical item. So when we see a physical item here, okay, this 100 rupee note, we all know what a 100 rupee note looks like. Okay, so this is a 100 rupee note, but this is not a physical item. Rather, if you see here, okay, if I can, not able to zoom it much, but if you read a 100 rupee note here, it writes, I promise to pay the bearer the sum of 100 rupees, and this is governor's signature. This is just a promise. Whoever has this note, whoever has this piece of paper will get 100 rupees. That is what this means. There's nothing called 100 rupees. Okay, this is just a promise by the government of India. The representative of government of India is called as the governor. That is why the governor is the one who has signed this note. And that is why, because we all believe in the government of India, that is why we value this piece of paper with 100 rupees. Okay, it's because of the signature. So any piece of paper that has a promise will be called as promissory note. If I give you a piece of paper writing, I will give you 500 rupees and I sign my name. Okay. If you believe in me and if let's say a third person believe in me, for us it's a legal currency. Because I have promised I'll give you for 500 rupees. If you too believe in it, you can give that note to the third person, and that third person will take that note to me and say that, sir, you have promised 500 rupees. Where is my 500 rupees? Right? So piece of paper where I promise something would be called as a promissory note. So this is also just a piece of paper that promises that whoever holds this piece of paper will get 100 rupees. So what's 100 rupees then? It's just a value. Okay, so this 100 on this piece of paper would be called as its face or value. Okay, it's called its face value. Whatever is written on face is called face value. Then what's a market value? Let's say exchange rate is a market value. You'll say $1. Okay, $1 is worth, let's say, 80 rupees. That becomes its market value. Right. In market, I can get $1 for every 80 rupees that I have. So that becomes its market value. Okay. So these are physical traits of money. Okay. At this point, what is the face value? That you can easily determine from that piece of paper. At this point, what's the market value? You can easily find that out from the exchange rate. Now there are some values that are not physical traits of money. Okay, and we call them as time value of money. Okay, these are the values that changes with time. So any value that changes with time would be called as time value of money. Okay. Now there are two modes by which we calculate the time value of money. The first is called as interest, and the second is called as inflation. Now these are the two modes or two factors which will change the value of money with time. That is why they are called as time value of money. So when I say this 100 rupees note that we have, that let's say I am carrying in my wallet, if I carry that 100 rupees for next 500 years, will that 100 rupees change to something else? Will this 100 rupees magically become 500 rupees? Will that happen? It will not. If I'm carrying it with me, it will not change to anything else. It will still be 100 rupees. Right? So how does time change the value of money? I'm saying time will change the value of money, but this 100 rupees, even in the next 500 years, will remain the same as 100 rupees. Okay. So the value will change in a different way. You might say inflation will decrease its value. Rather, what does the inflation do? We say inflation changes the purchasing power of money. So it's affecting the purchasing power of money. Due to inflation, if let's say in that 100 rupees you could buy, let's say 5 pen today. Now tomorrow, let's say the price of those pen, this just means one pen is worth 20 rupees. Let's say tomorrow the pen prices change to 25 rupees. So that means of those same 100 rupees, you can now only buy 4 pen. Right? So this is what we call it as inflation. So usually what we say is inflation is increase in prices, but actually inflation does not increase the prices because the value of that pen has not changed. Let's say I had a pen of 20 rupees, the same refill, the same ink, the same material, everything is exactly same. Then the value of the pen did not change. Okay. But the prices have increased. We say that the purchasing power of money has decreased. Okay. So inflation will decrease the purchasing power of money. Now we can purchase less items with the same amount of money. So this is how with time inflation will decrease the value of money. How would interest increase the value of money? Now interest will only affect the money that has been invested. So the money has to be invested. If I have 100 rupees in my wallet, it will not change magically into 120, or it will not change magically into 150, or it will not change into 500, even if I keep it for 1,000 years. So interest will change the value of money only if it is invested. So in finance, we say any money that we are considering is money invested. So we'll say money is always invested. There's no ideal money. Okay. So all money is always invested. I'll say all money. All money is always invested. So whenever we are talking about money, the money is always invested. Okay. So in this chapter, we are not going to talk about inflation. In this chapter, we are going to talk only about interest. So we have studied two types of interest. We have simple interest, and we have compound interest. Now, simple formulas of simple interest. If I say SI, I represent simple interest. I'll say it is P into I into T. P is the principal amount, I is the rate of interest, simple rate of interest, and T is nothing but the time for which it was invested. So if I say amount that I will have in simple interest would be P into 1 plus IT. Right? So simple interest and the accumulated amount. We'll use the word accumulated. You will understand that as we go along. In compound interest, we usually first calculate the amount that has been achieved after n years. So we say 1 plus I raised to n, okay. And the compound interest, we'll say it is the amount minus the principal. So 1 plus I raised to n minus 1. This is going to be my compound interest, the amount that I will get as interest. Anybody has any problem here? Simple interest formulas and compound interest formulas. You might have studied R by 100 as rate of interest. Okay, we are not going to write R by 100. We are just going to write I. Okay, 100 is already included. So if I say rate of interest is 7%, 7% means 0.07%. It already includes upon 100. Okay. So student, you might have learned R by 100 during your school days and college days, but we are going to just write it as I. Okay. 7% means 0.07. It does not mean 7. Okay, it means 0.07%. Okay. So these are the two methods by which we calculate interest. Now, can you tell me which one do we use usually? If I say I want to use one of them, can you tell me which one would we use? We'll use compound, right? So most of the times we use compound. So why do we study simple? Why do we study simple interest? Do we use simple interest? Do we use simple interest? Do you have any example? Have you ever seen anybody using simple interest in practical life, in real life? Saving account, no, saving account does not use simple interest. Saving account will definitely use compound interest. Loan will also use compound interest. Okay. Both are not the correct answers. We do use simple interest. Okay. We use it sometimes. But savings account and loan is definitely not the correct answers. In some kind of loans, you might have seen simple interest. Okay. But I would like to be a specific answer. Loan is not a specific answer. Now, by any chance, if you go to buy a two-wheeler, have you short-term loans? That's a very, very good answer, short-term loans. So, by any chance, if you go to buy a two-wheeler, in two-wheeler, you might get a loan for that two-wheeler. So the amount of two-wheeler, okay, two-wheeler right now costs anywhere 90,000 to a few, 1 lakh, 1,15,000, 20,000, something like that. So what happens is in two-wheeler loan, they will say, I'll give you loan at 9%, I'll give you loan at 7%. They are actually talking about simple interest. Now the reason they are using simple interest to calculate two-wheeler loans, there are two main reasons. I'll talk about the main reason later, but actually the reason they can talk about simple interest in a two-wheeler loan is because it's a short term and low value, low amount. It's a short term and a small amount. You can say small. Let's not use the word low. Let's use the word small. Small amount. So because it's a short term loan, usually a two-wheeler loan is going to be a 2-year loan. And the amount is about 1 lakh rupees, just above 1 lakh rupees maybe. Because it's a short term loan and the amount is small, that is why they use simple interest for calculation purposes. So there are many other cases where we still use simple interest, but the main reason we use simple interest is because it is a short term loan, and the difference between the interest, if I talk about simple interest or if I talk about compound interest, the difference between the interest will not be a big difference. Okay. So at a short term and a small amount, the difference between simple interest and compound interest will not be much. That is why we can use simple interest. And the reason we use simple interest is because it is easy for calculations. The word simple, right? It's simple. If I say that I give you 100 rupees as loan for 2 years, okay, so principal amount is 100. Time of loan is 2 years. Okay. In this case, let's say T. Okay. Rate of interest is 10%. Can you tell me how much will be the amount that you will return after 2 years if we are talking about simple interest? Simple interest. Can you tell me how much will you return? Yeah, 120, right? You'll say 10% of 100 rupees is going to be 10 rupees for 2 years. So P into I into 2, right? P into I into T will give me 20 rupees. Okay, so here I can say P into 1 plus IT, that is 100. 1 plus I will be 0.1, 10% will be 0.1 into 2, and that is just 120. 20, so 10 rupees per year per 100, that is the interest. Right. So I did not need any calculators. But if the same scenario, I say principal is 100 rupees, time is 2 years, rate of interest is 10% compound. Can you tell me how much will it be? We'll say P into 1 plus I raised to n, that would be 100 into 1 plus 0.1 raised to 2. If you are confident about your squares, you will be able to calculate. But you can imagine if I had given you 7%, it will be very difficult to find the square of 1.07. So usually this is a complicated calculation. Here the answer is 121. We can use calculator to do it. But simple interest, calculating this simple interest is easy. You can calculate it without calculator. So it's simple. And you can see the difference is just 1 rupee. Okay, the difference was just 1 rupee. So there's a small difference because the amount is less and the time period is also less. Okay. Time period is 2 years and the amount was 100 rupees. So for a short term and small amount, we use simple interest. Okay. So we said, simple interest is easy for calculation. Why don't we use it for long terms and large amounts? Why not we use simple interest every single time? Why do we need compound interest? Can anybody tell me? One answer is large returns. Anybody else? So compound interest gives me more interest, right? That's the reason. Okay, large return means more interest. Anyone else? Everybody agrees that this is the reason why we use compound interest? Now, for this, I would like everybody to answer. Let's say this is the scenario. Okay. Forget about 2 years. Okay. I'm not, forget about this short term and small amount. You can imagine we are talking about 20 years. You can imagine we are talking about 100 crore rupees. Okay. If I take loan from you, okay, you are giving me 100 crore rupees as loan for 20 years. Okay, you are giving me 100 crore rupees as loan for 20 years. Which one would you prefer? Would you prefer simple interest or compound interest? You can write S or C in comments. Okay, again, you are giving me loan of 100 crore rupees. So you are the lender. If you are the lender, everybody seems to be, going for compound interest. Okay. So everybody is going for compound interest. Right? That makes sense. You will earn more money. But let's say now you are the borrower. You are the borrower. Now everybody wants simple interest. Now when there are two parties involved, a loan is given, one person will be a lender and the other person will be a borrower, right? If the lender always says I want compound interest and the borrower always says I want simple interest, will there ever be a deal? No, right? There will not be a deal. Why would you pay more and why would I pay less? Right? That does not make sense. So the reason that we'll get more money in compound is not correct, because there will always be a borrower and there will always be a lender. Correct? So if lender wants more money and he'll get it in compound interest, then borrower wants simple interest because he'll have to pay less and will never come into agreement. So there will be no loans given, no investment given, nothing, because investment is a type of loan itself, right? So that is not the reason. Just because compound interest gives me more money, that is why we'll use compound, is not the reason. I'll tell you what the reason is. Let's say today you give me 100 rupees. Okay, you are giving me 100 rupees as loan. At time 1, okay, let's say rate of interest is 10% simple. Okay, simple rate of interest. at time 1, how much would I return you? At time 1, 10% interest, you would say return 110 rupees, right? 110 rupees I will return. Okay. Now, let's say you take that 110 rupees and give it as a loan to somebody else. Okay. You give it as a loan to somebody else for 1 year. So can you tell me at time 2 how much would you get? At time 2 you would get 121, because 10% of 110 will be 11, and you will add 11 to your 110 and you will get 121. And let's say you take that 121 and give it to somebody else, how much you will get at time 3? So 12.1% would be the interest, 10% interest, so it will actually be 133.1. Correct? So after 3 years, the same 100 rupees gave you 133.1 rupees as returns. Now let's say I come to you and ask for the loan for 3 years. I want to borrow the money for 3 years. How much will I return? I'll return 130, right? Because 10% is the interest, simple interest. Very easy, right? Okay. Now, do you see a problem here? If you give me loan directly for 3 years, you are earning less. Again, instead of 100 rupees, you can imagine it is 100 crores. So you have a loss of 3.1 crores. Would you give me then loan for 3 years? You would say no. You'll say, I will give you loan only for 1 year. And then if you want loan again, if you want that money again, you can return me 110 rupees and take that 110 rupees back for another 1 year. Right? You would say, I will give loan only for 1 year. Give me the money back, and if you want the loan, take immediately. Now let's say I'm a businessman, I own a factory, I have, I don't have that 110 rupees or 110 crore rupees, whatever you want to call it, readily available. I have a lot of product made, I have a lot of raw material bought. Money is in that, right? I don't have 110 crore rupees at my hands right now. And just so that I give you at time 1, I give you that 110 and you just give it to me back. That does not make sense. Correct? You will say again, after 1 year, return me the 121 and take it back if you want it again. And only for 1 year. I'll not give you more than 1 year loan. Right? So instead of that hassle, because I will have to sell all my product, no raw material at that exact moment, so that I can give you that 110 and you give it to me back. That hassle is too much for me. I'll say, okay, see, calculation wise, clearly, if you give me loan for 3 years rather than giving you 130, I will give you 133.1. Does that make sense? Right. Just give me 1 minute. Okay, I'll be back. Let's continue. Okay. So I would prefer, rather than giving you each year money to get that money back, I would prefer just to pay you this 133.1. Okay. And I'll say, don't ask me for money every year, just take 133.1 after 3 years. This is what your calculation says. Right? And if you see what this calculation is, what is happening here is this 100 rupees is my principal. If I multiply 1 plus I for 1 year will give me 110, right? I'll have 1 plus I into 1 year. Then similarly, if I take this 110 and another multiply 1 plus I for 1 year, I am getting 121, and 121 1 plus I is giving me 133.1. Now if I just substitute this, if I substitute here, what do I get? I get 100 into 1 plus I square is giving me 121, and then again with this 121 I substitute it here, I'll get 100 into 1 plus I cube is giving me 133.1. So this is nothing but compound interest. So compound interest is basically simple interest given 1 year at a time. Right? Compound interest is basically simple interest given 1 year at a time. We say we are compounding each year. We use the word compounding each year. It's like taking out the money and then reinvesting the whole amount for another 1 year. Then taking out the money and then reinvesting for another 1 year. So that is called as compounding. Or you can say you are getting interest on interest also. Right? So previously you would have said 10 rupees interest on 100, that is 110. Another 10 rupees interest would get 120, and another 10 rupees interest will give you 130. So each time you were adding interest on the same amount. You were not getting interest on the interest here. Right? But if you add interest here, you will get 121. And if you add interest on interest here, you will get 133.1. So that is called as compounding, giving interest on interest also. Correct? That's the simple way of explaining what compounding means. So compounding is used, or compound interest is used because it is consistent. Okay. Whether you calculate it for 1 year, here we had 1 year, whether you calculate it for 2 years, this was for 2 years, and whether you calculate it for 3 years, you will always get the same answer. So we use compound interest because compound interest is consistent. Okay. And we use simple interest because simple interest is easy and easy for calculation, easy to calculate, and does not have large difference for small amounts in small time periods. Okay. So the reason we use simple interest, still use simple interest, is because it is easy to calculate and does not have a large difference for small amounts in small time periods. Okay, if we use for small amounts and small time periods, it does not give me a large difference compared to compound interest compared to compound interest. This is the reason we still use simple interest. Okay. Now, when it comes to simple interest, I'll give you a simple example where we can. It makes more sense to use simple interest rather than compound. Okay. Let's say you buy raw material from me. Okay. But usually what happens is when you are buying the raw material, you may not have the complete money to pay then and that time only. So usually what happens is after 3 months or 4 months, you will process that raw material and sell the complete good. So at that time, you would pay me the raw material prices, okay, the cost for the raw material. So basically today you are taking raw material, but you are paying me after 4 months. Okay, you're paying me after 4 months. Somebody else is also taking raw material from me, but they are paying me after 2 months because their process is different. Okay. So usually what happens is in business, you may not be able to pay at that time itself, but you will pay it after sometimes. So what I'll say is, rather than me worrying about whether you are paying after 1 month or whether you are paying after 2 months or 3 months, I'll say, okay, how much ever you time you take, just give me 1% per month as interest. Imagine if this was compounding. Okay. So let's say for 100 rupees, how much will it be for 4 months? How much will it be for 2 months? How much will it be for 3 months? It's very difficult to calculate. But if it is simple, it's very easy to calculate. For 2 months, it's 2 rupees per 100 rupee. For 4 months, it is 4 rupees per 100 rupees. Right? It's so easy. So it is easier to do calculation when it is simple interest. And that is why we still use it. Now at the beginning, I told you the example that for simple interest, two-wheeler loans use simple interest. Now the reason they actually use simple interest is because the interest amount seems to be less when we are talking about simple interest. They will not use the word simple interest. They will say we are giving you interest at 9%. But please remember, we'll learn this in later on chapter. We have a whole chapter on loans. Okay. Later on we have a whole chapter. This is the chapter. Okay, this is the chapter on loans. We are going to learn that this 9%, where are we? This 9% simple interest is equivalent to, or you will pay the interest of similar to as 18% compound. Okay. The same amount of interest that you would pay in 18% compound is same as simple 9%. Right now it might seem counterintuitive. We always say we are paying less interest in simple and more interest in compound. That is what we say. But when it is loans, it becomes opposite. I'll explain that again when we come up to that chapter. I'll remind you this. So by any chance you are going and thinking about buying a two-wheeler and you are buying it at loan, remember whatever rate of interest they are offering you, ask that whether it is simple interest or compound interest. And if they use the word simple, remember to just make it twice if you are comparing it with any other compound interest loans. Okay. We learn that in loans chapter. Okay. So simple is okay if you are paying it at once. That means I am sort of taking a loan at time 0 right now. I'll pay the whole amount at time 4 months. Then simple is fine, no problem. But if I am paying an EMI, that is what you will usually pay when it comes to two-wheeler loans, then always choose compound interest. That will give you a better idea. Okay. So as I said, we'll be learning later, we'll be solving it, and you'll understand exactly what I'm saying later. Okay. So one thing, again, if you have any doubts, please do ask, don't hesitate. Okay. So here we are talking about a loan of rupees 500 is taken by Abhay for 4 years at the rate of interest of 7% per annum. Find the amount returned after 4 years and the total interest paid if the rate was, first is simple and the second is compound. Okay. So simple interest. So principal amount is 500, interest rate is 7%, and the time we are talking about is 4 years. Now whenever we are talking about simple interest, the it's very important that the units of rate of interest and units of time matches. Okay. So the rate of interest is given in per annum, that means per year, then the time should also be in years. If the unit of rate of interest was per months, then we would have taken time in months, right? That is how we should match the units. That's going to be very important. So simple interest, you can just say it is Pi into T, that is 500 into 0.07 into 4. Okay, so people have calculated it, that is 140. Okay, and therefore the accumulated amount after 4 years You can either directly say the principal plus simple interest. That would be 500 plus 140 is 640. Okay. Or you could have calculated it using P into 1 plus IT. That would also work. That will also give you the same answer. The second compound. Same principal amount is same. Rate of interest is same. Now, when it comes to compound interest, one thing you should always remember is that at the beginning, in this chapter at least, we would want the rate of interest always in per annum and the n, that is number of years, always in years. Okay. So for compound interest, we'll say the rate of interest is given in per annum basis and the number of years or n should be given as number of years. Okay. So for this we'll calculate the amount first. It's just easier to calculate the amount first. We'll say P into 1 plus I raised to n. Okay. So for this we should require a scientific calculator. Now the calculator that you will be buying, now see, we have two institutes. If you are giving the examination from IFOA institute, that is the UK based institute, then you should buy Casio FX 991 ES Plus. This is the calculator. If you are giving the examination from IAI, that is the Indian based institute, you should buy Casio FX 82 ES Plus. Now both are very similar in functionality as well as looks, but clearly 991 will have more functionality than the 82. Okay, so 991 will have more functionality than 82, but these are the calculators that are allowed. Okay, so we'll buy these particular calculators according to the institute. Now for learning, I will be teaching you, these are scientific calculators and you will not have any problem in learning them even if you have never used a scientific calculator. One thing you should always make sure is that it should be the ES version. There are MS versions also available, but do not buy the MS versions because there is some functionality in ES that is not possible in MS and we will require that. So do not buy the MS version, it should be the ES version. Okay. Right now it is, what do we say? There is first edition, second edition does not really matter. Okay. So let me just show you. Okay. So this is how your calculator, this is the second edition of the calculator. This is how it will look. And this is the first edition of the calculator. This is how the old calculator used to look. There is no difference in functionality. Only the look has changed. You will not have any problem if you have the old calculator or whether you have the new calculator. Okay. And if we talk about 82 years, okay, new calculator, you will see that it looks almost the same. Okay, 82 years also looks similar to 991, and this is the old calculator. This also used to be very similar, just the color was different. Okay. So again, you will not have any problem in the calculator. Okay. So these are the calculators, and when it comes to learning, I will be teaching you. So I am using an app. So I'm using an app that has almost the same layout, same functionalities. Okay, so if you are downloading scientific calculator as an app on your phone for practice purposes, just make sure that you have these 4 arrows in between, because in our calculator we use something called as navigation buttons. These are the navigation buttons in our calculator that we use for navigation. It is also present here. You can see 4 buttons. So if you are using the app for calculation for practice, make sure you download the one that has these 4 navigation buttons. Okay. So this is a scientific calculator. In this scientific calculator you will see that we have the normal buttons, okay, plus, minus, multiplication, division. Everything is similar in this lower part, but if you see the upper part, we have some extra functionalities. Okay, so you can do integration directly. We'll talk about that later. Okay, you have square, you can have any other power with this box. You have root, you have division, you have log. Ln is natural log. You have trigonometric buttons. We don't use trigonometry, so you don't have to worry about these buttons. You have brackets, you have this S, D, M plus. There are a lot of functionalities. Now one of the easiest things is we can just do this. Okay, 500 plus, I'll just show you 500 into 1.07. Now I want raised to. For raised to, I will use this x raised to this box. Okay, so if I press that button, you will see I get this power, and you can see that my cursor is in the power now. You can see that red cursor in the power. I'll press 4. Now I can directly press equal to, but let's say I had to write something else. I want this cursor down. To bring this cursor down, I will have to use this navigation keys. That is what we use this navigation keys for. Okay, so this and then equal to, and we get, okay, so 655.398. Okay, one question, can we use app in the examination? No. Okay, you should not. You should buy a physical calculator. It's going to be very important. Rushil, you are asking if I use FX82ES1 for IFOA. See, IFOA has no restrictions on calculator. So your examination is online. They say we are not able to check which calculator will you use. So we'll put no restrictions on calculator. Okay, so IFOA has no restrictions on calculator. You can actually use app, but I do not recommend it. I recommend you buy a physical calculator and practice on it. It's just much faster if you use a physical calculator rather than using an app. Okay, I said app just so that sometimes you forget bringing the calculator and we need some method, so we can use scientific calculator on your phone as well. Okay, so you can use 82ES in IFOA. You will not have any problem. Any functionality that we require in IFOA examination is present in that 82ES plus. Okay, IAI are strict, even though their examination is going to be online, but they are going to ask you to show that which calculator are you using. Okay, so that is why 82ES we have a restriction on calculator. Okay. So throughout our course, I am going to teach you how to use the scientific calculator. You will not have any problem to use the calculator. Okay, so this is our accumulated amount. So clearly compound interest, you can say accumulated amount minus the principal. So it is 155.398. That's our compound interest, right? Any problem here? Simple interest, compound interest. Okay. So if you have any other question related to institute, related to anything else, we can talk about it. Okay. I would like to continue the topic tomorrow. Okay. So if you have any other question, you can ask me. Now see, the calculator. I will just show you a quadratic equation being solved so that you understand how do we use the basics of this calculator. So a quadratic equation, if I have ax square plus bx plus c is equals to 0. This is our quadratic equation. We say the roots of this is going to be minus b plus minus under root of b square minus 4ac upon 2a, right? So let's say I make an equation. I'll say 2x square plus let's say okay, let's make 3x plus 4 is equals to 0. Let's say this is my quadratic equation. So I cannot have plus minus both of them together. So first I will just use minus. I want to make a fraction. So here I have this upon button. So I'll press that. I get a fraction. You can see I am at the numerator of the fraction. So I'll say minus 3. Then minus under root. I have an under root button. You can see besides that fraction. I'll press under root. Okay, b square. So 3 square. Let me just change this so that this does not become negative. Okay, so I'll just do this minus. Okay, I'll just make c as negative. Okay. So I'll have minus 4 into a. A is 2. So 2 into minus 4. Okay, I went outside the root. So I'll just press. It just happened because I was navigating here and there. It would not happen. I'll show you from the beginning. So fraction, then minus 3 minus root 3 square, and then minus 4 into 2 into minus 4. Okay, c is minus 4. Now I have to come down. I will use this navigation keys. So this is the down button. I'll press the down button and you can see now my cursor is down. Right. Upon 2 into 2. Here you go. One of my roots is going to be minus 2.35. And the other answer, if I want to, now I want to again just edit the previous equation. To edit the previous equation, I can just press this upper arrow key and all the equations that I have are still present. You can see here up arrow and down arrow. So I want to edit this. I'll just press now the side arrow key. Side arrow. So now my cursor is here. I will come here. I'll delete the minus and add a plus equal to. So these are the two roots. Now many times your answer will be given in fractions. Okay. Here you can see it is in decimal, but many times your answer might be given in fractions. In such cases, what you have to do is you have to press an SD button. You can see above del you have an SD button. This is converting your fractions into decimal, decimals into fraction. So when I press this SD button, this time this is the fraction that it is showing, but if it was a small fraction, that is what it would have shown. This is the simplest fraction. Okay. So SD, convert your fraction into decimal in the answer. Like if I have 45 divided by let's say 18. Okay, 45 divided by 18 is 2.5. Now if I want to convert this into fraction, again SD, I'll press that. You can see 5 by 2. Press it again, 2.5, 5 by 2 and 2.5. So this SD button would convert your answer from fraction to decimal, decimal to fraction. Then you understand the use of this decimal, this division, root, square, and this log. These will help you construct a very complicated equation. So any complicated equation, you can construct it here itself, okay, in your calculator. So if I have, let's say log of 2 square plus 3.5 minus 2. Let's say this is the equation. I can directly make this equation in my calculator. I'll press log. For log, I will have this ln. Ln is natural log, that is log to the base e. Okay. Then 2 raised to, for raised to again x box. Okay. Now I can make an equation in this box itself. I don't need to just write one single value. I can say 2 plus 3.5. That all came in the power. Now I just press the down button to come down from that power. You can see the cursor is now down here. Say minus 2 bracket close is equal to. What's the difference between log and ln? Log is base 10. Okay, log is always base 10. So I'll say log is same as log base 10, and ln is log base e. Okay, now what happens is in our books, whenever we use the word log, we actually mean ln. Okay, very rarely you will find that log would mean log to the base 10. So in most of the books you will find log is nothing but natural log. It means base 10. But in this calculator, log actually means base 10. So that is why I have started practicing writing ln. This you will find as we go along that I write ln. I don't write log. Even though in book it is written log. Because my mind was trained that if I am writing log, I should press this log button. And I used to get wrong answers. So I started training my brain to write ln so that I press ln in the calculator. Okay. So there is a difference between log and ln in the calculator, whereas in your books, whenever they write log, they actually mean natural log, that is ln. So anyways, as you start practicing, you will realize it, and either you write log and press ln here, or you can just write ln both places. It will not matter. Okay. Now, other than that, you will find there are some things written above these buttons as well. They are written in yellow and purple. Now, whatever, these are more functionalities. So if you want to use anything written in yellow, you will press this shift button first. There's a shift button you can see here. I'll press the shift and use any of these yellow functions. If I want this purple functions, I will press this alpha button. So let's say I can also do combinations, permutation combinations. I hope everybody has learned. So NCR is nothing but n factorial upon r factorial n minus r factorial. This is how we calculate NCR. So if I want, let's say 10C5, okay, that would be 10 factorial upon 5 factorial, 5 factorial. I don't actually need to calculate using factorials, although there is a factorial button as well. You can see here above x raised to minus 1, you will see factorial, right? So I can actually use that. I can say 10 shift and then raised to minus 1. So I press shift and then pressed this raised to minus 1. Okay, I'll show again. I'll go down, 5 shift and this into 5 shift this equal to, I have 252. Okay. Now I can directly make this 10C5 as well. I can directly calculate the combination. You will see down here in multiplication and division, above that you have NPR and NCR. You can see here in yellow NPR and NCR is written. Okay. So if I want, I can just say 10 shift and then press this division. Okay, I get a C. You can see C and then press 5. So that is 10C5, and you can see we have the same answer as 252. So you can use combinations and permutations, that is also a functionality directly given of our calculator. Okay. So we'll be learning as we go along, we'll be learning more functionalities of the calculator, and there are many unique functionalities. If you press mode, you will find a lot of different modes. We'll not be using complex mode, but statistics we'll be using. We don't use base n, but table we'll be using, matrix, vector we don't use. So maths, statistics and table, these are the 3 modes that we use. Now in our FX 82 ES plus, we have only these. We don't have this complex, we don't have this base n, we don't have matrix and vectors, and that is fine, because in our examination we'll be using this math, that is our normal calculation mode, the stat mode and this table mode. That's the main modes that we are going to use. So you will not require the other modes. Okay, and that is why I said in the examination you will not have any problem even if you are using this 82 ES plus. Just this 991 ES plus, this is more common in colleges. Okay, that is why I recommend that. And there are a few things. Differentiation and integration is something that is not part of this 82 ES plus, but it is part of 991. Okay. And even though you can do differentiation integration without the calculator, but if you have it, for especially if you want to check, it becomes a little bit easier. Okay. So even if you have this 82 ES plus, no problem. As I said, make sure that you have the ES version of any of these calculators. ES version, not the MS version. Okay. So tomorrow we'll be meeting 10:30 AM. 10:30 AM to 12 will be our class, and I'll be talking about the class. We'll be continuing this topic, and other than that also we will be talking about class. We will be talking about what would be our future timings and stuff. If you want, you can ask me anything about actuarial science, anything about S.MONK. Okay. Otherwise, you can also see below me that you have that phone number. You can call or WhatsApp to get any information about us. Okay. I hope I'll see you tomorrow at 10:30 with the same link. Okay. And we'll continue the topic here. Bye.